أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم فقال ربكم ادعوني أستجب لكم آمين يا رب العالمين الحمد لله رب العالمين الرحمن الرحيم مالك يوم الدين إياك نعبد وإياك نستعين اهدنا الصراط المستقيم صراط الذين أنعمت عليهم غير المغضوب عليهم ولا الضالين آمين اللهم اجمع شامل المسلمين والكريستيان والأمة في مدينة دباو وسلم دائما مجتمعنا هذا بالسلم والأمن والتقدم في بلدنا هذا آمين يا رب العالمين ربنا لا تزغ قلوبنا بعد إذ هديتنا وهب لنا من لدنك رحمة إنك أنت الوهاب ربنا إنك أنت الوهاب ربنا آتنا في الدنيا حسنة وفي الآخرة حسنة وقنا عذاب النار وصلى الله على خير خلقه سيدنا محمد وعلى آله وصحبه وسلم سبحان ربك رب العزة عما يصفون وسلام على المرسلين والحمد لله رب العالمين آمين يا رب العالمين.
In the name of the Father, Son, and Holy Spirit. Amen. Our most gracious Heavenly Father, we come to you today to praise and worship you and give you thanks for all the things you continue to provide for ourselves and our families. Father, we humbly ask for forgiveness for all the times we have offended you, when we forget to acknowledge your presence in the image of our brothers and sisters, and for moments we fail to be good stewards of the blessings you have given us. Continue to guide and protect each one of us, Lord, that we may always walk in the lights of your everlasting love and mercy. Grant us, Father, with your comfort in times of distress and with your strength in times of weakness. Bestow upon us your unending grace and healing, that we may in turn become instruments of gentleness and compassion to others. We ask all this in the name of your Son, our Lord Jesus Christ, with the prayer and the intercession of our Blessed Mother. Amen.
Okay, good afternoon to our teachers all over the country. Welcome to our 18th session of our It's a MATHtech Day Casio Technology session. So for this afternoon, we'll be discussing another topic to be presented to us by very competitive, very not very competent rather, competent and knowledgeable speaker in the field of mathematics. And today he will be discussing to us about exploring some Math Olympiad problems using technology. So, hindi natin patatagalin pa. I'll introduce our speaker this afternoon. He is an assistant professor at the Department of Mathematics at Ateneo de Manila University, a graduate of Ateneo de Manila University, Bachelor of Science in Mathematics, and a graduate of Purdue University MS in Mathematics, and he finished his PhD in Mathematics at Purdue University, a leader of the Philippine Team to the International Mathematical Olympiad from 2016 to 2019, and a director in the 23rd Mathematical Olympiad. It will happen this school year, and he was able to bag gold medals for Philippine teams from 2016 and up to 2018. Let us all welcome our speaker this afternoon, Dr. Richard B. Eden. Hello, sir. Good afternoon. Sir, nakamute po yata. Sorry po. Ayan.
Hold on.
Hello,
Okay,
sir.
okay.
Good afternoon.
Magandang hapon sa lahat ng mga nakikinig, Teacher Bads. Thank you for the introduction. Good afternoon. Okay, and that and okay.
Yes, po. So I'll give it to you na po, sir.
Okay.
We're going to see each other again later.
Okay, thank you very much. So I was approached by, my friend, Mr. Joel Serrano from Casio Philippines to give a talk about problem solving and also technology. And at first it seemed to be a daunting topic, but I'll explain that when you do problem solving, there's always a place for whatever tools are available. So did Teacher Bads mention my experience with mathematical Olympiads a bit? So as a mathematician, my expertise is in pure mathematics. So I teach, I do research, but on the side, I am also involved in many efforts in the country which are related to mathematical problem solving. So and specifically contests. So I've been involved with the, I suppose it's okay to mention, the Metrobank MTAP DepEd Math Challenge, the MMC. And Teacher Bads mentioned that this year I'm the director of the Philippine Mathematical Olympiad, which is going to be a challenging situation because of the COVID situation, the pandemic. But you know what? For some of us who are able to, who are healthy, and we of course are mindful of the whole situation, but we try to do our best given the situation. So we're gonna push through with the Philippine Math Olympiad. I was team leader of the Philippine team to the International Math Olympiad. So you could think of this as the Olympics of Mathematics. And the Philippines has only won 4 gold medals. So the credit ultimately goes back to the students who we trained. And our students, they're really amazing. They are really talented if given the opportunity. I understand, given the news about TIMS, which just came out earlier this week, it is clear that much still has to be done. But while there are many different challenges, so you have to take care of the students in the general population, you could try to contribute in your own small way towards other tasks as well, such as training students to try to be the best that they could, whether at the level of their school or their division or the Philippine context as they participate in a math contest, or even at the international level. So I would like to talk first about mathematical problem solving. So I'll be presenting a slide, which I will make available to everyone later. But first, allow me to proceed with it. Okay, okie dokie. Give me a few moments. And all right, here we go. Okay, so exploring some Math Olympiad problems using technology. I'd like to first make a distinction between what an exercise is versus what a problem is. I think most of us are going to be familiar with exercises. So my teaching experience is limited to the college level, and most of the audience are probably teachers at the elementary level or the high school level, although I will have to ask your indulgence because a lot of the problems I've selected for today are skewed towards the high school context rather than the elementary context. But the general idea of problem solving and exploration, this is universal across grade levels. So what's an exercise and what's a problem? An exercise is something that's routine, and you basically just need to know what you have to do, and you just need to follow an algorithm. So I see this as being very similar to following a recipe from a cookbook. So it was not you who thought of how to figure out how many of this to mix with this other ingredient. You're just following things. And an example of an exercise is when we solve a quadratic equation such as this. Solve for x in the equation x squared equals 16. For a high school student who knows how to solve quadratic equations in general, succeeding in such an exercise requires just knowing the quadratic formula or knowing how to factor, or it just entails knowing how to complete the square. On the other hand, a problem is something that's not so familiar. It's going to require creativity and is more akin to a puzzle or a case that a detective has to solve. So here's an example. Fill up a 3x3 grid with the integers from 1 all the way to 9. So that the sum of the numbers in each of the 3 rows, and there are going to be 3 columns as well, so and also the sum of the numbers in each of the 3 columns, and then there are going to be 2 diagonals, all these sums, so that would be a total of 3 plus 3 plus 2, so there are going to be 8 sums. So you want all those 8 sums to be the same, and the task is, how can you do that? How can you fill the 3x3 grid with the integers from 1 all the way to 9 so that this condition is satisfied? Now, if you think of the skill that's required in this example, it's being simplistic, but when it gets down to knowing how to add numbers, knowing how to add 3 numbers, there's not even any trigonometric function that's involved here, no exponential functions, it's just addition. We're not even adding fractions, we're not subtracting them, we're just adding integers. But it doesn't make this example an easy problem to solve if you give this to someone in grade 4 or grade 5 and he or she is seeing this for the first time. It's not going to be easy. So how does one solve a problem like this? Do you do trial and error? Do you make a guess? Do you make a guess? So you're in a dark room, you don't know where the switch is, you don't know even if there's a switch, and therefore it could get scary a little bit because of the unfamiliarity. As compared to an exercise, you have a quadratic equation. If you cannot factor it, then at least you can use the quadratic formula. So with an exercise, you're sailing on smoother, calmer waters. When you're solving a problem, you don't have a map, you don't have a compass, you don't know where you're going. You're just hoping that eventually you'll get at the right solution, at the right answer. Now, the distinction between an exercise and a problem, these are not clear-cut because familiarity is an important aspect of what makes something an exercise and what makes something a problem. For example, I have a daughter, she's in grade 1, and the other day, I think that they were solving this problem, fill in the blank. Blank plus 3 equals 5. Now, for us, we could easily fill in the blank. It has to be 2 because we're familiar with all the properties of addition and subtraction from grade school arithmetic. But for someone who is seeing addition for the first time, you're going to be taken aback, because if you're not yet familiar with subtraction, then what you're doing is you're thinking of a number which, when added to 3, will be equal to 5. So that particular fill in the blank exercise is an exercise to someone, but to another person, it's going to be much harder and it will be a problem. Now, even though problems require higher level thinking than exercises, we're not shooting down exercises. Exercises are still important. They are very important, just like problems are, because, well, even though the K-12 curriculum guide in mathematics highlights problem solving, exercises are important because exercises are a test of skill. And for you to be able to do more complicated, higher level processes, you have to be proficient at the more fundamental skills. For example, if you're a novelist, you can't go too far if you don't know the basics of grammar, of syntax. You're not going to be able to convey everything that you want to say in a beautiful manner if you don't know the basics. Knowing the basics is necessary for you to be able to go to much higher levels of thinking. So exercises are necessary, but problems are also necessary. Although, because of our limitations, even not during the pandemic, but in a regular classroom setting, we tend to give more focus to exercises. I'm a college teacher, so I also teach college students. So most of the things we do are skewed towards exercises. So what you could do is try to strive for the opportunity to solve problems whenever the opening comes up. So as I said, even the DepEd curriculum guide highlights the importance of problem solving. It says there that the twin goals of mathematics in the basic education levels from K to 10 are critical thinking and problem solving. So hopefully now that we are more familiar with the distinction between exercises and problems, well, we're going to be solving problems. We are going to be exploring problems in today's session. Polya, a mathematician, defines mathematical problem solving as finding a way around a difficulty, around an obstacle. It's finding a solution to a problem that is unknown. All right. So again, exercises are more focused on developing fluency, whereas problems are opportunities to demonstrate mastery and understanding. So these are higher level things. Okay. So problem solving, math problems are important. Even though most of the classroom discussion is focused, skewed towards exercises, let's try to explore, if possible, problems. Well, problems are something that you're going to see regularly in math contests, in math Olympiads. However, when we ask students to solve problems, it doesn't have to be at the level of a math Olympiad. Even in regular classroom settings, you could probably try to infuse aspects of problems. So for example, in the situation I mentioned earlier, instead of just having students subtract 5 minus 3, asking them to fill in the blank, blank plus 3 equals 5, what's the blank? So if that's something unfamiliar, then that turns the situation into a problem for a student. But for today, I'd like to talk about problems at the context of math competitions. So mas mataas na level. I've been asked before, why do we join contests? Ano ba nakukuha natin sa mga math Olympiads, sa mga math contests? I think we could ask the same question about sporting events. And the columnist George Will said in a column that sports serve society by providing vivid examples of excellence. And it is actually a gratifying thing to see that, well, not everybody's going to be a good singer or a good boxer as our famous athletes. We strive towards becoming better. We see how if we pull our resources together, we can produce something good, or these people can produce something good out of their own efforts and out of their own initiative. And personally, it's my dream that while there's nothing wrong with cheering for beauty pageant cyclists, for athletes, for our artists, and they're really doing a good job promoting our country to the rest of the world. It is our hope that our students would also be recognized in the same way when they represent our country in various academic competitions, not just math competitions, not just in the International Math Olympiad, but other contests as well, be it in mathematics or chemistry or physics, because they provide examples of excellence. They push the glass ceiling that, hey, we can actually do a good thing if we put our resources towards a good endeavor. When you solve mathematical problems, so I'd like to mention the importance of creativity. So creativity is needed because you're dealing with something that's unfamiliar. So halimbawa, nung 3x3 grid that I mentioned earlier, right, you need to be creative to be able to solve such a problem. And while there are going to be some techniques that you could use along the way, creativity in the end is still going to help you. So later on, as we explore math problems using technology, we are going to be using one particular strategy, which is finding a pattern. So this is similar to when a scientist works and a scientist tries to come up with a hypothesis. He or she is trying to observe a phenomenon. He or she is trying to observe nature and trying to make sense out of it. And that's what we're going to do. Mathematics is the science of patterns. So we're going to look for patterns, and we're going to see how technology can be a tool towards unearthing some of these patterns. All right, so you know what? Let's get straight down to it. One of my mentors, former Ateneo President Father Ben Nambres, who is an advocate of mathematical problem solving, not just at the college level, but also at the grade school level, laments that how a lot of young people, of course not everybody, but there's a tendency towards instant rewards because of the easy access to things on the internet nowadays. So nawawalan ng patience, nawawalan ng grit. And grit, patience, perseverance, these are very important in problem solving. So even if you embark on problem solving, not just for the sake of mathematics, there are some skills along the way, such as grit and perseverance, because ultimately, when you look at life's problems, they're not straightforward. You don't know even if there's a solution, but grit, just punching your way through and hoping for the best outcome, these are the things that are going to carry us through. So let's start with one particular problem, which is, because it's a problem and not an exercise, this may be unfamiliar. What I'm going to do is I'm going to move on to another notebook, which I'll be sharing. Okay. Where I'll be writing down solutions. Okay, so I'm going to share the whole screen so that I could share the calculator that I'll be using. Okay, so I'll be using this calculator. And first, let me open this notebook. Teacher Bads, is this visible? I want to make sure that I'm sharing the right thing. Okay,
yes, sir. Yes, sir.
This. Okay, so thank you. The slide that I showed earlier, I have not yet uploaded them here. So what am I sharing? If you follow the link here, bit.ly/Casio Prob Solve December 12, it's going to lead you to, if you open this on your browser, you'll be able to access OneNote. So I don't think you have to download it. Instead of typing that link, if your gadget has a QR reader, you could also use this QR image here. Instead of typing it, it's going to lead you to the same thing. Because what I'll be doing is, well, we're going to try to unravel certain patterns in certain mathematical problems. They will not be the end of the problem. All right. Whenever we unearth a pattern, whenever we come up with a hypothesis, we would like to be able to prove that it is correct. So when we solve some of these problems, there are going to be two parts. We're going to look at a pattern, and then if there's time, let's try to prove it. Okay. So the first problem, so I've talked about exercises versus problems and Olympiads as a mirror of excellence. So this is the first problem that I'd like us to discuss. So define the following function. F of x is equal to 1 over 1 minus x. And denote r iterations of the function f by f superscript r. So the superscript r there is not an exponent. It represents the number of iterations of applications of the function f. So compute f superscript 2021 evaluated at 2020. Just in case that's raising eyebrows regarding what that means. So George Polya says that one of the first things you have to do when solving a problem is you have to first understand the problem. So if there's something unfamiliar with the notation, try to experiment first, see what's happening. So f superscript 1 is nothing else but f evaluated at 2020 using that function. And then f superscript 2 would be 2 successive compositions of the function f evaluated at 2020. So I just wanted to write it down, just so we're all on the same page regarding the meaning of what it is we have to solve for. Because if we don't understand what it is we have to solve for, then we wouldn't be able to identify what it is if we don't understand what it is that we are looking for. Now that's quite daunting. You have to apply the function f 2021 times successively. Now, whenever you see a problem like this, which involves a particular task being done so many times, it would be not feasible to expect the solver to actually apply the function 2021 times. So what we're going to try to do is see if there is a pattern. Now, some problems, some competitions rather, depends on the context. For example, the MMC, you have to, it's old school. You have to solve it by hand on your own. Although I think Casio has a contest where you could use technology to solve problems. So my philosophy here is that whichever method is available when you're solving a problem, exploit that method, highlight it. You use that method. So of course, in a contest, you have to follow the rules. If you can't use a calculator, then by all means, do not use a calculator. But sometimes I dabble and solve problems in preparation for example, training students for competitions. And even though solution manuals are available, even though solutions to some contest problems are available, it still feels different if you're able to explain a problem because you went through the thought process on your own. No, hindi mo lang basta binasa ng solution at kinuwento sa kanila, pero kasi sinolve mo din ng problem because then you get to explain why you thought of doing a particular step. Bakit ganito nang ginawa mo? Bakit mo in-square ng both sides of the equation? So, kasi ikaw mismo, ginawa mo yon, so mas kaya mong i-explain. So here, let's try to get our hands dirty and start with evaluating f at 2020 and then applying the function again a second time. So here's what I'm going to do. So I am going to make the view screen larger. Oh, by the way, so I'm using FX570991EX. So this is visible on the screen. So I accessed, so in the menu, in the setup, so you have these options. So I already had this opened when I started. It's in the menu, so there are different menus. One is for calculation, and because here we want to analyze numbers which are being processed here, you're applying the function f, a spreadsheet will be helpful. So I've selected a spreadsheet. I'm going to click enter. And then here's what I'm going to do. I'm going to start with typing 2020. So I guess I'll just go ahead and type 2020. Okay. Now, what I want to do is look at the result of applying the function on 2020. And the operation described by the function is 1 over 1 minus x. So because this is something that will be repeatedly done, what I'm going to do is I'm going to type down a formula. So the equal sign is, so you have shift here in orange and alpha in red. So these buttons are going to help you access all the functionalities in orange and red respectively. So I'm going to click alpha. And when I click this button, that's going to access the equal symbol. And then 1 divided by, grouping symbols are important, 1 minus. I'm going to access 2020 in cell A1. So to capture A1, I'm going to click alpha, and then this button above the minus sign, because above it is that red A, and A is what gets typed, and then I'm going to type 1. So that's going to reference cell A1. And then close the group, and then equals to execute, implement. And that's what happened. That's the result. Now, that's the result of the first application of the function. Because we want to apply the function a second time, instead of writing that same formula all over again, let's copy that formula. So I'm going to go back to the cell with the formula I want to copy, and I'm going to click Option, and then all right, so it has 1, 2, 3, 4, these options. What I need are the options following. So I'm gonna click this button at the top, which goes down. And number 2 is copy and paste. So, okay. So that formula has been copied, and then I'm gonna click the down button in cell 3, and then it says here paste is done by clicking equals. All right. And that formula is still copied. I'm going to go to the next cell and then click equals. All right. So that 0.9995 is the result in cell A3 is the result of applying the function on the number in cell A2. And the number in cell A4 is the function applied on cell A3. So as you go down through the various rows, they correspond to the results you get on each successive application of the function f. Therefore, what we see in row number 4 is the result of applying the function 3 times. I forgot I could actually pop this up, make the display larger. Sorry about that. Okay. But what do we notice here? What we notice here is that we, after 3 rounds, after 3 applications of the function f, we ended up with the same thing, which means that if you're going to apply the function f another time, you're going to get that -4 times 10 raised to -4 in cell A2. And then another application of the function f will give us that number in cell A3. So what this illustrates to us is there is a pattern in the resulting values. All right, so if we want to describe what's happening here, we could write it down as follows. So f sub 1 of 2020, and then you get f sub 2 of 2020. So that's the second application, and then f, I said sub, I meant superscript. Okay. On the third application, which we see in row 4, we got the same result, 2020. Which means that if we're going to apply the function f one more time, that would be the 4th application. It would bring us to that number, which is approximately -4 times 10 times raised to -4. And then the second application would lead us to what we see approximately as 0.9995. I'm sorry, I should have given more space here. All right, so this is the result of the 4th application, and then this is the result of the 5th application. Now, as I'm writing this down, I understand some of you may already have seen a problem like this before, but I suppose it's safe to assume that there might be some of you who are seeing a problem like this for the first time. And so if you're seeing a problem like this for the first time, then the insight we get out of this is certain tedious tasks, perhaps you don't need to do them 2021 times. Maybe there is a pattern, and if you understand what the pattern is telling you, then you'd be able to figure things out. So, and then this is what you get out of 7 iterations and so forth and so on. So we have row A, row B, and row C. The question now is, there are now only 3 possible values. Which one of these will be the value we need? The application of f 2021 times. If you look at row C, these are the results of applying the function f 3 times, 6 times, 9 times, the number of times a multiple of 3. So if you look at 2021 times, that's not a multiple of 3 because, well, the sum of the digits is 5. But if you look at f applied 2022 times, so that's going to be a number that's divisible by 3 because 2 plus 2 plus 2 is 6. All right, so that means f superscript 2021 times is equal to the value you get out of the second application. And so if you look at the calculator display, the second application of the function f is at 0.9995 rounded off to 4 decimal places. We would want to provide an answer that's exact, but the advantage of our method here is that we at least know what we're looking for. All right, so what we need to figure out is the same as f applied 2 times in succession. So what you could do here is, if you want to do it by hand, so the first application will be 1 over 1 minus 2020. You could, of course, use your calculator to do this. So you would maybe have to go back to the main screen because, of course, it could do fraction calculations exactly. So this is -1 over 2019. You're going to have to tell me if I'm doing my arithmetic incorrectly. So the second application would therefore be f evaluated at the result of the first application, -1 over 2019. So this is 1 over 1 minus, and then -1 over 2019. So this is 1 over 1 plus 1 over 2019. And then for, I think it's grade 5 or grade 6 where the simplification of fractions is done. So you should be able to figure things out. So you could have your own strategy on how to simplify. Personally, what I do is I multiply the numerator and denominator by the integer that would clear all denominators. So 2019 plus 1. So it's 2019 over 2020. So the final answer is close to 1, and that is consistent with 0.9995 being a number which is quite close to 1. All right, so are there any questions? Before I move on to the second problem, what I have prepared are 9 problems. So I'm not sure if we're going to be able to explore all of them, but it's better to have more problems. With some of them we end up not using than run out of problems to talk about. So I was informed by Teacher Bad that if there are comments, you should be able to send it to him, and then I should be able to address whatever comments you may have questions at the middle. Otherwise, I'll go on to the second problem. Okay, so you could access the notes that I'm writing down using, again, for those who maybe just tuned in a little bit later, to this link, bit.ly/Casio prob solve December 12, or you could use this QR code. And it's going to lead you to your browser, open it up to this same notebook. So you can see what I'm writing down, so you can follow and review and go back to earlier solved problems at your own convenience. All right. I don't have titles for these problems, so I'll just go down to the second problem. All right. Find the square root of 1 more than 999 dot 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 999 times 100 dot 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 001, where you have 2018 digits out of the nines in the first factor, and in the second factor we have 2019 digits, not just the zeros but also the ones. So in the second factor you have 2017 of the zeros, and the leftmost and rightmost digits, which are both 1, fill up the 2019 digits. What do we have to do here? Find the square root of 1 more than the product of these two numbers. So this is a problem which can be addressed, solved using algebra. However, if this is a contest or you're just interested in knowing what the answer would be, then the pattern that we're going to try to unravel will shed light on what the answer is supposed to be. Now, of course, we are not expected to type 2018 times for the first factor. And we are also not expected to key in the second factor with 2019 digits. I just don't think that each of these factors would fit in our calculator, aside from the fact that it's probably going to take us a very long time to type all the digits just from each of the factors. And there are 2 factors. And then you can just imagine the computation that would have to be done. But just like the preceding problem, maybe we don't have to apply the function f 2021 times. Maybe all we got to do here is find the pattern. Okay, so that we could save time, just like the first problem, I decided not to write down the full complete solution anymore. What I just wanted to illustrate was the pattern pointed out, and for us to realize how we could use the pattern in the preceding problem to come up with the answer. So we're going to do the same thing here. Okay, I have instead a second calculator, which I'm going to use now. All right, so FXCG50. All right, because this has more functionalities. Now, calculators, of course, are one coherent piece, but one of the people who are organizing pointed out to me that I could remove that top portion so that it could be magnified so that it would be easier to see the things that I'll be writing down. All right, so first let me clear this. How was I able to access this anyway? Okay. To be honest, I'm not sure how to. Okay. So just like the earlier calculator that I used in the preceding problem, this is a calculator which has various modes. It has more modes. It can even draw triangles and it can draw geometric shapes. There's a geometry mode. However, I decided not to solve any geometry problems today because, well, maybe due to limitations. So we're going to be focusing more on algebra, number theory, unearthing patterns with sequences of numbers. So, and also their digits. So one of the modes here is the spreadsheet mode. Let me first clear this. So at the bottom of the screen, you see File, Edit, Delete, Insert, Clear, and the right arrow. These are 6 buttons, and to access them, you have to click F1, F2, F3, F4, F5, F6. So delete corresponds to F3. Let me clear everything. All is a third, so I'm going to type F3 again, and so that's going to clear the table. After clicking F1 for yes, to confirm that I'm going to delete everything. All right. So the problem involves, well, multiplying that expression, 999, many times, and then 10001. So two factors, but the second factor just has one more digit than the first. So one strategy, aside from trying to find a pattern, is to solve a simpler problem. For example, from a grade school perspective, what has to be added to 276 in order for the result to be 532? So it's clear to us who are more experienced that the operation you need to do is subtraction. But if you present something like this to a student in grade 2, it might throw the student off. So you could start perhaps by asking the student, well, let's make the number simpler. What should be added to the number 2 in order for the result to be the number 5? And if the student says 3, then you could ask again, well, what can we do on 5 and 2? What operation to produce the number 3? So that's an example of solving a simpler problem, because if you're able to find the essence behind the solution to a simpler version of the problem, then that could help in solving the much more complex version of the problem. All right, so let's start by multiplying similar looking numbers but with fewer digits. So I'm going to start with 9, and then, all right, that's in cell A1. So I pressed EXE to enter it. And then 2 digits with ones at the leftmost and rightmost. So that would be 11. All right. And we're really interested in the square root of one more than the product. All right. So I'm going to do the calculation there. So because I am going to apply the same computation on more complex versions, I would like to input the computation as a formula. So here the functionalities are quite different. So I'm looking for the equal symbol that has to start a formula. That equal symbol is above the period, the dot at the lowest row, which is in orange. So I'm going to click Shift in orange, and then that key, equals. And then the operation was square root of one more. So where's the square root function? So the square root function is this shift and then above x squared. Square root of one more. So just to be safe, I'm gonna use a grouping symbol, 1 plus the product of the two entries, A1 and B1. So to access the letters in red, or red, A, B, C onwards. So I'm going to click alpha, and then A1 times alpha, and then the B key above log, B1. And then I'm going to close the group and then click EXE, execute. All right. So this is the square root of one more. Now for the next row, the first factor would have to be 99. I could implement the successive addition of a digit 9 by doing the following. On the number above it, which is 9, I'm going to multiply it by 10 and then add 9. So I'm going to type in this formula, shift equals, and then 10 times the number just above it in cell A1. So alpha to access A1. So far, this should be 90 and then plus 9. All right, 99. Then I'm going to go back up to B2. What I want to write there is 101. So one way of implementing that is from the 11 in cell B1, subtract 1. That's going to give you 10. And then multiply it by 10, so it's going to become 100, and then finally add 1. So let's key in that formula. Shift equals. All right, 1 plus, so 1 plus 100, which is 10, times the number in cell B1. So to get 10 out of that from 11, let's subtract 1. So the entry in cell B1 minus 1. So alpha B1 minus 1. And then close the group. Okay, so this formula, let's just check that it's going to give us the right thing. B1 is 11 minus 1, it's 10. So that has the effect of removing the rightmost one. And then multiply by 10, so from a 2-digit number, it becomes a 3-digit number. And then finally, add 1, which I happen to have written as the first term, para lang tapos na. And then execute 101, which is correct. And then for the square root of 1 more times the product, all we gotta do is copy the formula in cell C. And I can do that by clicking, let me see if I remember, option. No, hold on, sorry. I'm gonna exit, okay. Oh, edit is under the screen. Edit is the second function, so I'm gonna click F2. And then the second function there is copy. So F2 again. When pasting to Excel, paste from cell C1. All right, now with the formula copied, see how on the screen it now shows paste. It's ready to paste. I'm going to click down and bring the cursor to cell C2, and I'm going to click paste by clicking F1. So now at least a pattern is showing up here. So we have the result is 100. It's 1 followed by 2 zeros. And you can think of the fact that there are 2 zeros because the first factor, 99, has 2 digits. So let's see what's gonna happen. I suppose you could already think of what the pattern would be. For the next row, it's gonna be 999. And then the second factor would be 1001. Perhaps you could already come up with a conjecture here that the result would be 1 followed by 3 zeros, 1000. You don't have to type down each of the formulas. To this time, copy the 3 formulas from cells A2, B2, and C2. This particular calculator has a clip functionality. If you look at the number pad above 8, you see there clip. Wait, first I'm going to exit the paste mode because I'll be copying. So here's the exit button. Okay, and then exit all the way out. All right, so shift and then clip. Shift, clip, and then what it shows you is cell A2 all the way to A2. But I want to copy the formula in cells A2, B2, and C2. So I'm going to go to the left, right, down, up keys, and then click right, and see how B2 is also highlighted all the way to C2. If I go further, all right, so now I've highlighted the formulas in A2 up to C2. They are what I want to copy. So this time I'm copying not just 1 formula, but 3 formulas. So the copy function here is in edit, the second one. So click F2 and then copy. So F2 again, and then paste. So all I gotta do is go down to cell A3 and then paste by clicking F1. And then pasting to the next row now becomes so much easier. Press F1 again, and then press F1 again when you go down to cell A5. So where the result happens to be 1 followed by 5 zeros. So if all we are interested in is finding the answer, okay, so from the pattern, okay, so the pattern is that 9 times 11, there so, all right, the square root of 1 more. So this becomes 10. And then the square root of 1 more, then the product 99 and 101, is equal to 100. I think we've already seen the pattern. So therefore, so our conjecture, so this is assuming that the pattern works. The square root of 1 more than 99 where we have 2018 digits, times 1001, where we have a total of 2019 digits. If our answers above were 10 to the first, and then this is 10 to the second, then we anticipate that our answer here is going to be 1 followed by the number of zeros equivalent to how many 9 digits there are in the first factor, which is 2018. So therefore, our conjecture is that the answer is 10 raised to 2018. Okay, so what we did here is we made the conjecture, we made a deduction on what the answer should be by looking at easier versions of the problem, because of course it's not going to be feasible to actually carry out the division by hand mechanically without looking at a pattern. So that's what we did here. So if there are any questions or comments, I'd be happy to hear from the gallery, from the audience, what you think about these problems, or if there are concerns. Now, there is, of course, a second layer to these problems, because in science, when you try to come up with a hypothesis, you don't end there. You don't just come up with a hypothesis and say that, oh, this is really what's going to happen. You have to test your hypothesis. In mathematics, testing the hypothesis requires proving it or giving a justification to the problem. And that can be done here by using algebra, because that's what I'm going to do now. So you can use technology to come up with a hypothesis, but proving is still going to rely on the human element, the cognitive element, where you think things through and try to come up with a proof. So what we're trying to do here is we're multiplying 99999 with 100001. Now 9 with 2018 digits. Well, you could think of this as 1 with lots of zeros minus 1. And 1 followed by, it would have to be 2018 zeros. All right. And then when you subtract 1, that's going to give you 99999 with 2018 digits. So of course, a more compact way of writing this is 10 to the 2018 minus 1. So this is the proof. And then with 1, where you have 2019 digits, it means that after the leftmost one, you have 2018 digits following it. So you could write this as 10 raised to 2018, but because of the rightmost one, then it's really a plus 1 afterwards. And so therefore, what the problem is asking us to compute is the following: the square root of 1 plus the product of the two factors, which are 10 raised to 2018 minus 1, and then 10 raised to 2018 plus 1. And in fact, you could generalize this to the following: 1 plus 10 raised to the power n minus 1 multiplied by 10 raised to n plus 1. So from the pattern that we saw, we are at least comforted by the fact that, alam natin in the end, this would be simple. So at least it's easier for us to hope that eventually everything's going to fall into place. Kasi nakita natin dun sa patterns that we looked at that in the end, this is really going to be simple. So let's multiply. What you have here is a special product of the form a minus b multiplied by a plus b. So the result from high school algebra is a squared minus b squared. Remember, a minus b times a plus b is a squared minus b squared. So So when you multiply those two factors, it's going to be the square of 10 to the n minus 1 squared, which is 1. But of the three terms, we then see that the first and the third terms are going to cancel because they're both 1, leaving us with the square root of 10n squared. And that's squared. And then when you take the principal square root, that's going to be 10 to the power n, where n is the same exponent of n here. And that is justification why in the case where the exponent n is 2018, the result at the very end is 10 raised to the exponent 2018. So we saw the pattern. We are aware that everything is going to fall into place. Things are going to be fortunately not so complicated when we get to the final answer. So that makes us confident as we pursue the justification that yes, indeed, the answer should be 10 raised to 2018. And in fact, in the solution that we wrote here, the number 2018 appearing in the exponent, there's really nothing special with that. That's why in the spreadsheet that we came up with, so the pattern applied to various rows. All right. How is everyone doing? We are on the second problem. So as you can see with regards to unearthing the pattern, we didn't really use algebra, maybe a little bit with the scientific notation with, well, it was really just recognizing 99999 is a power of 10 minus 1. So we used exponents and then a little bit of algebra in the solution. Okay, so again, for those who just came in, my solutions here can be accessed in bit.ly, Casio Prob Solve December 12th. So I thought it would be okay to go back to this just to provide a break between the different problems we will be solving. All right. Maybe I'm gonna skip to, no, okay, let's go to my third page, find the following sum. Now, what I have here are two similar problems, and they're gonna be of a similar variety, so maybe I'll just do the problem in the first box, that particular sum computation, and then for the second box, if we run out of time, of course, you could do that. Or if we still have time, we could go back to it. So momentarily, I'm going to move this down when I write down my solutions. Well, I'll write down my solutions later. But first, let us explore the first computation. Evaluate. Find the exact value of this sum. 1 over 1 times 4. Plus 1 over 4 times 7, plus the next term, the third term, would be 1 over a denominator of 7 times 10. So the two factors in the denominator differ by 3. So starting with 1, you have 4 is followed by 7, and then by 10, 13, 16, and so forth and so on. And then it can be justified that 2017 and 2020 are also going to fit that pattern. Actually, you could verify because I noticed 1, 4, 7 are integers which are 1 more than a multiple of 3. So 1 is 0 plus 1. 4 follows 3. 7 follows 6. And if you look at 2017, yes, it follows 2016, which is a multiple of 3. 2020 follows 2019, which is a multiple of 3. So, all right, at least we know that very last term deserves to be there. Find the sum. Well, how many terms are there? There's a lot of terms. And are we going to do this by hand? I suppose you could do this by hand if you have nothing else to do. Kung walang kailangan lutuin, kung walang anak na aalagaan, kung maraming papel. But even if you have the time and the resources, well, this is rightly a problem we don't want to really get into the tedious computations because, well, hopefully there's a pattern. Well, the fact that I've included it, yes, there's a pattern, but well, let's try to figure out what the pattern is. So what I am going to do is try to write things down on a spreadsheet. Now, one complication is that if you look at the first term, well, okay, that's 1 over 4, 0.25. That's exact. But 1 over 28, when you try to write it down as a decimal, then in a spreadsheet, I think if you carry out a division, what you're going to see is the decimal approximation. I suppose if you go to the main mode, then you're going to see 1 over 28 in the fraction form. I don't think, well, let's just try it anyway. Okay, because we are adding many terms here, what we want to do is to capture, to be able to put in our spreadsheet the individual terms. And then afterwards, let's worry about adding them all up. Okay, so I already have this particular calculator open. So let me move the notebook here to the side, just so you can still see the terms. And then here is the calculator. I'm going to try to minimize the window so you can see everything. The sum, the series we want to compute, and the calculator. It's on paste mode, so I'm going to click exit. What I want to do is to clear the entire table. I'm going to exit again, and then delete is the third function. So F3 and all at the bottom of the screen. F3 again, because all is the third. Delete all, yes. So F1. All right. Okay, what I want to be able to do is capture the factors appearing in the denominator. 1, 4, 7, and then 10. So I'm going to start with cell A1, starting with 1. Execute. And then the next number is 4, which is the number in cell A1, but we want to add 3. So let's use a formula, shift, to access the orange equal sign in one of the buttons in the last row, and then cell A1. So to access A, so alpha, and then A, and then cell A1 plus 3. And then execute. So what we're going to get out of that is a formula that we're going to copy onwards down to generate the numbers 1, 4, 7, 10 onwards. Now for the very first term, all right, we want 1 over 1 times 4. So equals, so shift and then the equal sign, and then 1 divided by, just so it's safe, okay, open parenthesis, so everything is grouped. We want to multiply 1 and 4, which are the numbers in cells A1 and A2. So alpha A1 times alpha A and then 2. At least we can verify the first term is 1 over 4, so this should be 0.25. Okay. And then what we need to do for the next is to copy this same formula. All right, so let me do that. So exit, and then edit. So F2 to copy that, and then copy F2, that's the second function. And then we're going to paste it here, and then paste. So F1. Oops, I think I made a mistake. Exit. Oh, all right. It's because, okay, I know why there's a mistake, because there's nothing yet that's placed in cell A3, which should be 7. So I suppose the formula maybe is counting that as a 0, but I expect the formula, the number to correct itself once we've copied the formula and 7 appears afterwards in cell A3. Okay, but for now, what I want to do here is to, you know what, just so it's clear, let me, okay, exit, okay, and then copy F2 for the copy and then paste. So I'm going to click F1. It should, a 7 should appear here. And there you go. In cell B2, that should be 1 over 28. Now, what we're really computing are not the individual terms, but rather the sum of the succeeding terms. So what you could do is consider the following simple problem. Instead of looking at the sum of all those many terms, why not look at the sum of the first 2 terms, the sum of the first 3 terms, or the sum of the first 4 terms, the first to the 5th terms added. So let's keep on adding the terms one by one. So that's what we're gonna write on column C. So to do that, I'm gonna go to cell C1. I'm gonna copy what's in B1. So that would be the first partial sum. So it's not yet the total sum, but we're adding the sums partially. So one by one. So let me copy what's in cell B1. So shift equal sign, and then wait, I should exit paste mode. So I'm gonna click exit here, exit. All right. Okay, I'm gonna copy cell B1. So shift equals. All right, so I know I'm on the right track because the equal sign appeared there on the screen on the input bar. And then B1, so alpha B, and then 1. All right, so 0.25. Now, what I want to do is on the sum that we currently have in cell C1, 0.25, add the latest term, which we're seeing in cell B2. Okay, so the formula for that is, so shift, so it could access equals there. And then the sum so far on cell C1, so shift, and then letter C above the natural logarithm. Oh, sorry, I should have clicked alpha for red. Sorry, I can't see colors now. So, okay, delete alpha C. C1 plus the latest term, B2. Alpha B2. All right. So 0.25, 0.2857, and then to continue with the rest of the table, we can just copy what we have in cells A2 up to C2 and then go down the wire. Okay, so we've done that already. First, we have to select cells A2 up to C2 because that's going to be more than one cell. We're going to use the clip feature. So clip is above the number 8. Clip is in orange, so let's click shift in orange and then clip. So highlighted, it's just cell A2. Let's move the right arrow until we get to C2. So A2 up to C2 is highlighted. To copy that, edit by accessing F2, and then copy on the screen is the second, so F2 again. So now that it's been copied, we're ready to paste it. So let's move the cursor using the arrow buttons to cell A3. We're going to override 7, but it's okay because it's the same formula we're copying. Paste, let's click F1. Okay, press exit. Again, it's the same error because it's supposed to be, one of the terms is supposed to be 1 over 7 times 10, but 10 is not yet in this spreadsheet. So I'm going to go down here and then paste again, F1. All right, so at least in row 3, umayos na siya. So it's just a bit troublesome, but we keep on doing this, and eventually, as soon as we fill up the missing numbers, all right, the numbers will be all right eventually. Okay. Tapos sige, if we want lagyan natin ng 19 dito. 19. Oh wait, I'm gonna exit. Tapos let me type 19 here. So aayos na yon. All right. Now the partial sums are what we see in column C. Unfortunately, because they're decimals, we don't have, well, it would be so much better if we have fractions. But anyway, okay, let's see what we have here. Okay, so the first few terms are the following: 1 over 1 times 4, plus 1 over 4 times 7, plus 1 over 7 times 10, plus 1 over 10 times 13, and then lots more to follow. Out of the first, we do have 0.25. From the first two, that's the 0.2857. And then from the first three, that's 0.3, which is, all right, there, 0.3. Well, it's not clear what's really happening because we don't have these numbers in fraction form, but we could try to anticipate what they are. For example, 0.25, let me write this with a different color, red. So we know 0.25 is 1 over 4. What about 3 over 10? Sorry, I went ahead of myself. 0.3, I wanted you to think of this as a fraction, and I just blurted it out, 3 over 10. Well, if you look at the denominators, the denominator from just the first term is 4. And the denominator for up to 3 terms is 10. And we at least see those denominators here, 4 and 10. So 0.2857, of course, that's not exact. This is just a 4 decimal place approximation. Maybe this is a fraction with denominator 7. And then it's just an issue now of figuring out, well, what's the numerator going to be? Well, to determine what the numerator would be when we rewrite that second sum, 0.2857, as a fraction with denominator 7, well, to figure out the numerator, let's multiply 0.2857, the result in cell C2, with the number 7. So let me go back to the calculator and let's go back to the calculator and let's go to let's use column D. So the number in cell C2, so alpha, of course, equals, and then alpha C, and then number 2. And I want to multiply that by 7, but instead of typing 7, I noticed that 7 is one of the entries in column A. In fact, it's cell A3. So let me type cell A3. So alpha A, and then 3, and let's see what the result's going to be. Oh, it's the number 2. That means the sum of the first 2 terms is a fraction with denominator 7 and numerator 2. So we see here that when you add successively, the sums are 1/4, 2 over 7, 3 over 10. So we could conjecture that when you add the first 4 terms, it's going to be a fraction. And can you figure out what the numerator would be of that fraction and what the denominator would be? Let me try to move down this box. So if we add the first 4 terms, so we are conjecturing, is this going to be 4? Because you're now up to the 4th term, and then the denominator would be 13. The larger of the 2 factors in the denominator, 4 over 13. So how can we verify that that's 4 over 13? Well, we already have the decimal approximation out of the 4 terms in cell C4. In cell C4, the partial sum is 0.3076. Is that 4 over 13? Well, to verify, let's multiply it by 13 and see if the result is going to be 4. In fact, why don't we copy the formula that we have already input in cell D2 and then copy it to all the other entries, to all the other cells in column D. And we anticipate that column D should give us the numerators 1, 2, 3, 4, 5. We're guessing that's what's going to happen. So let's see. Let's go to cell D2 and copy it. So edit, copy, okay, accept it, and paste. So let's go to cell D1 and then paste. In cell D3, paste, clicking F1. Cell D4, click F1 to paste. Cell D5, click F1 to paste. So again, the meaning here is that in cell D5, 5 is the numerator when cell C5, 0.3125, is multiplied by 16. And so therefore we have a pattern here. So from the pattern, okay, so if we call this S, okay, so our conjecture or our guess here is the following. Our sum is equal to a fraction with denominator equal to the larger of the two numbers that are being multiplied in the denominator, 20, 20, and then the numerator would be the order of that last term when you write them all up. So this is term number 1, term number 2, and then we just have to figure out this is term number n. What is n? So you could try to just think about how, for the first term, maybe you could do it this way. From the first term, the larger denominator 4 is 1 more than 3 times 1. And in the second term, the larger factor in the denominator is 1 more than 6. And note that the number we ended up multiplying to 3 is precisely the order of that term in that summation. So then that means we got to figure out 2020 is 1 more than 3 times what? And that number we have to multiply to 3 would then have to be the value of n. It would correspond to how many terms we have here in this sum. So we just need to do 2020 minus 1 divided by 3. So 2019 divided by 3. If I'm doing this right, of course, you could use a calculator, but so that I don't have to switch anymore, this is 6, 18, and then 21 divided by 3 is 7. 9 divided by 3 is 3. So this is 1 more than 3 times 673. So this is the 673rd term, term number 673. And therefore, our conjecture is that the sum is 673 divided by 2020. Well, of course, it is possible to deduce the pattern by actually adding all these fractions by hand and, well, ultimately use whatever tool is available. But I mean, if you have a tool that's available, you're free to use that. Sometimes, depending on your facility, you could perhaps be able to carry out certain computations by hand on your own, but then we're different people. Sometimes certain calculations, you could do it in your head, but sometimes you're not confident. And so if you want to make sure that you're not going to make any mistake, you could use a computational device. Because sometimes ultimately, we want to be able to focus on the pattern. sometimes if you're able to use technological devices, you're not that tired when you get to trying to figure out what's happening. Hindi nung pagod na pagod ka na sa pagmumultiply, litong-lito ka na, so hindi mo na maisip ng pattern. But again, it depends on the situation. Okay, so we are actually just here on this particular problem. I'm sorry about the speed that I'm going through. I don't know if I'm too slow or if I should make it faster. I wonder if, sorry, I haven't been looking at if there are comments. Teacher Bads, are there comments or wala naman?
I think most of the comments, sir, are just greetings.
Oh, okay, greetings. Okay.
Yes po.
Okay. Okay, good afternoon. Sige po, magandang hapon sa inyong lahat. Kung mabilis po o mabagal, ito ng hirap kapag kunwari nasa isang classroom, madaling basahin ng body language kung nalilito or kailangan ng further clarification. So, I'm open naman kung kailangan bagalan o kailangan bilisan. But otherwise, I'll proceed with the next problem. It's already 4:25, so I have more problems than I think we're going to be able to cover. So itong find the sum, you could try doing something similar. For this problem, okay, kasi how do we know that the pattern holds true? So you could prove this. Okay, so let me just, as an addendum, okay. How do we know the pattern holds in general? Okay. So how do we know the pattern holds in general, or how can we verify it to be true? Well, you could verify a mathematical fact by proving it. So how can we prove it? So ito depende na sa level. Kung kunwari, you are providing this as an exploratory problem to grade school students. Understandably, these might have to be really talented grade school students where they're not yet exposed to proving, then perhaps the exploration itself would already be enough. But for a STEM student who is familiar with mathematical induction, then this could actually be considered an exercise in mathematical induction. What we have to do is, from the pattern that we observed, try to write it down in its full generality. So what we have here is 1 over 1 times 4 plus 1 over 4 times 7, followed by 1 over 7 times 10. So I pointed out that 4 is 1 plus 3 times 1. So that's the first term. 7 is 1 plus 3 times 2. And this number 2 here corresponds to this being the second term. And then 10 here is 1 more than 3 times 3. This underlined 3 corresponds to this being the third term. What if, in general, we have n terms? In the discussion above, there were 673 terms. So if we want to describe the behavior in general, then we would like to write it down all the way to the nth term. So what would the nth term be? It would have the following denominators. The larger factor, sorry, it would have 2 factors in its denominator. The larger would be 1 plus 3 times n. And the smaller would be 1 plus 3 times n minus 1. Or so that's going to be 3n minus 3 plus 1, so minus 2. So the last term is 1 over the smaller factor, 3n minus 2, the larger factor, 3n plus 1. Our conjecture is that this series, this sum is equal to a fraction where the denominator is the larger factor in the last term, 3n plus 1, and the numerator will be how many terms there are, n. So we can now think of this as an exercise in proving a mathematical fact by math induction. All right, so this can be proved by math induction. Of course, there is another solution which does not require math induction, but we don't have time for that, as all these problems have lots of varying solutions and we just don't have the time to explore all of them. So that's actually one good thing about problems that appeal to me, about how there are sometimes multiple approaches. And also it's because I'm not sure if everybody in the audience is that familiar with mathematical induction. So just this is just, like one step towards finally providing closure to this problem. If you're familiar with math induction, then this is the statement that you have to prove. As a student, the question for students who are learning math induction, sometimes statements like this seem magical. Parang meron pinapaprove that, oh, the sum of the first n positive integers is equal to this, and the sum of the first n squares is equal to the following formula. If the formula is given and you're proficient with math induction, then you could prove it in a straightforward manner. But then before that, there's the underlying question, saan nanggaling ng formula? And sometimes to discover the formula, you may have to do something similar to what we're doing using whatever device is available, be it a calculator or a spreadsheet or pen and paper. Whichever tool is available, whatever you need, use whatever you need. So at least you have the formula, then you know what you have to prove by math induction. All right. Now,
Sir Richard, na-mute po kayo. Sir Richard, naka-mute po.
How's this? Hello?
Yes sir, okay na po. Okay na.
Narinig ako, Teacher Bads?
Yes po, Sir Richard, okay na po. Clear na po.
Stop ko muna sharing, then let's try to... Teacher Bads, how's the audio?
Okay na po, sir. Clear na po siya. Loud and clear.
Okay.
Yes po.
Ito, malinaw na?
Yes po. Oh. I think we're just having some technical difficulties with Sir Richard, Dr. Richard Eden. So let's wait. While waiting for Sir Richard, Dr. Richard Eden, let's have a short video clip. And I think he's now ready. Sir Richard.
Break
Hello, sir.
Malinaw?
Yes
audio.
po.
Okay, sige.
Yes po.
Tuloy po natin. Pero anytime na kunwari tapos na po ng time, sabihan niyo lang po ako. I've lost track of time. Di ko alam up to what time tayo. So, okay, sabihan niyo lang po ako. Okay, so the entire screen. Okay, and then the next problem is this one. Ito. Okay. Show that the product of any 4 consecutive positive integers is not a perfect square. Okay. Wow. So we want to show that a certain number, certain quantity. So ito siguro unang pagtingin, paano gagawin yun? How do you show something is not a perfect square? Well, one reason why this might seem difficult at the start is, well, we don't understand what's happening. So how can we understand what's happening? In problem solving, sometimes you just need to get your hands dirty. The best way to learn problem solving is to actually just solve problems. And sometimes you start by exploring. So do an initial exploration and see what's happening, come up with a hypothesis. And once you have a better understanding, then maybe that's going to give you an idea of what you need to prove or what you need to justify. So, okay. So let's have a look at the product of 4 consecutive positive integers. So, ganito gagawin ko. I'm gonna use this table. So, I'm gonna exit the paste mode so that we could clear this. So, exit until I get to where I see delete, F3, and bye-bye all numbers, F3. Delete all, yeah. Okay, so I guess the smallest such product of 4 consecutive positive integers would be 1 times 2 times 3 times 4. So when you multiply those 4 integers, oo nga no, 24, hindi perfect square. So then you could also have a look at 2 times 3 times 4 times 5. And then tuloy-tuloy lang. But then we want to be able to generate enough data for us to be able to hopefully understand why are these products not perfect squares. So I'm gonna in cell A1 start with 1, and then in cell B1 I'm gonna write down the product of 4 positive integers starting with 1. So, and then we're going to build a formula out of that. So shift, and then equal sign, and then so cell A1, alpha A times A1 plus 1. So that would be the next consecutive number. So alpha plus 1. And then the next factor, so open parenthesis, alpha A1 plus 2, close, and then multiplication, open parenthesis, A1 plus 3, alpha A1 plus 3, close, and then the result should be 24. Okay, 24. Tapos, for the next product, the first factor is going to be 2. So gawin natin yung cell A1, currently with the entry 1, let's add 1 to it. Para nung pag-copy natin ng formulas, convenient. So shift, and then equal sign above the dot, A1, so alpha A1 plus 1. And then we just want to copy this formula, 24. So to copy it, so, ano ba yan? Exit, and then edit, F2, copy, F2, and then we should be able to go down and paste it. So down arrow, paste, using F1. All right, so 120, you can check that's not a perfect square. Tapos to generate more data, let's now copy cells A2 and B2. So we want to select more than one cell in the range. So we're going to use the clip function. First, this is in paste mode, so I'm going to exit. Click exit. So, ayun, okay na kasi copy cell na downstairs. And then shift, and then clip above 8. And then right arrow to be able to span up to B2. And we're going to copy what's been selected. Click F2 for copy. And then go down to cell A3, so we can now go on pasting. Click F1, 360, and then 840, and then onwards, 1680. And then how do we know these are not perfect squares? Well, you can take the square root. It's kind of obvious with 24 that it's not a perfect square. Why is 24 not a perfect square? Kasi it's between 16 and 25. What about 120? Why is it not a perfect square? Well, because 120 is between 100, which is 10 squared, and 111 squared. And between any two consecutive perfect squares, you can't find any perfect square in the middle of them. So by perfect square, of course, we mean the square of an integer. Of course, you could always punch in your calculators the square root of 120, but when you take the square root, it's not going to be an integer, and that's why 120 is not a perfect square. So with you trying to think out loud in terms of trying to understand, 24 and 120 are not perfect squares. Well, we need to understand, why are they not perfect squares? Does anybody have a conjecture here? So far for the preceding problems, I've been the one who's been trying to raise the conjecture, the behavior, the pattern here. For those who are looking at the screen as we speak, and in column B, you do see here products of 4 consecutive positive integers, and they're not perfect squares. Does anybody have any idea why they're not perfect squares? So I don't know, Teacher Bads, if you're going to receive a reply from someone, but I just want to see if someone has a conjecture. Why are... Okay, far wala.
Yes, sir. Parang wala pa po. The last comment was posted last 4:33 p.m. So we're still waiting sa mga answers po nila.
Okay. So sige.
Okay, there's a
anyway.
comment here, sir, from Sir Glenn Ibanez Gilongos. Add 1 to make them a perfect square.
Okay, thanks, Sir Glenn. All right, these are not perfect squares because they are, in fact, 1 less than a perfect square. Nung 24, so we were talking a while earlier about how it's between 4 squared and 5 squared. It's between 16 and 25. And, well, okay, 24 is, isa na lang ang kulang, 25 na. 120 is between 100 and 121. Oy, nung 120, isa na lang, 121 na. So ito, nung 360, maybe it's not a perfect square kasi 361 is a perfect square. So if you want, you could just compute using your calculators, and you can verify that, yes, indeed, 361 is a perfect square. So is 841. So is 1,600 perfect squares. Okay, so the reason these are not perfect squares is because they are 1 less than perfect squares. Okay, so kung kasunod mong number, and the one following you is a perfect square, then you cannot be a perfect square. Because if you look at the perfect squares, you have 1, and then 4, and then 9, 16, 25. We actually see the gaps between them increasing. So as you go further down the line, it's impossible to find 2 integers consecutive to each other which are perfect squares. In fact, the only time that's going to happen is when you look at 0 squared and 1 squared. They are the only perfect squares which are consecutive because their values are 0 and 1, but, well, 0 is not going to be a possible answer here because in our problem, we are multiplying positive integers. All right, so now the next question would be, okay, these are 1 less than a perfect square. So nung 25 and 121 and 361, 841, so they're perfect squares, but they're the squares of what? Okay, so what we could do is, I'm thinking we could add one more formula here. Okay, tingnan natin so nung 24, kung dadagdagan natin 25, so perfect square siya, so square ng alin? Square ng 5. So let's fill in column C with what the square roots are going to be when we add 1. So we have shift, and then equal sign, and then the square root, That's very simple is, okay, shift and then above x squared. And then one more than what we see in column B. So B1. So alpha B1. And then let's close the group. Sorry, I think dapat nalagyan ko ng opening doon, no? So open and then 1 plus, I know there should be an easy way to just insert, right? B1, and then close the group. Ayun, 5. Then let's copy it. Copy is already visible, so wait. Okay tayo. F2, copy it, and then paste. Okay, so F1, so 11, and then 19, and then 29. So I wonder if there is a pattern there. So 5, 11, 19, and 29. Sometimes what you could do is look at differences, how they're changing. From 5, you jump by 6 to get to 11. From 11, you jump by 8 to get to 19. And then from 19, you jump by 10 to get to 29. All right, so at least with our exploration, what we have seen here is that, okay, so from our exploration, from getting our hands dirty, so we've seen that, okay, if you multiply n, and then n plus 1, n plus 2, multiplied by n plus 3, this is in fact going to be 1 less than a perfect square. Okay, this is why, therefore, this can't be a perfect square since, okay, since okay, hold on, okay, nung mouse, it's a bit jumpy. Okay. Therefore, this can't be a perfect square because since no two positive perfect squares are consecutive. All right, but for us to be able to actually put a lid and to be able to justify this argument completely, okay, so the rest of the proof would have to be, so we have to justify that, all right, the product P is really 1 less than a perfect square. Or equivalently, we have to show that P plus 1 is a perfect square. So when you look at a problem like this, just an initial look, you're not gonna know yet what you have to do. And that's akin to a genuine problem solving. When you look at a problem, you don't know what's really happening here, so you really have to exert some effort to try to understand. And as I mentioned earlier, I was talking about grit and perseverance as observed by Father Ben Nevres, former, it's actually not national scientist, former Athenaeum president. Right? It's this is a useful skill, having grit and being comfortable with frustration and knowing that you have to persevere. Na hindi lahat ng problem na dapat unang tingin, alam mo nang agad. So much so that pag tingin mo sa problem tapos hindi mo alam kung paano isa-solve, susuko ka na kasi you're expecting that it should be easy, things should be easy, but actually not everything is going to be easy. And so we have to have that state of mind to be able to handle things which are not going to be easy. And that is actually a valuable trait to have, to know, to find comfort in the fact that things are not always going to be easy. All right. So, para lang matapos natin itong this particular problem, so here's what I'm going to do. In fact, what you could do is actually just expand the whole thing and see why p plus 1 is going to be a perfect square. So p plus 1, let me write down 1. 1 plus n, and then n plus 1, n plus 2, and then n plus 3. Okay, so ito, algebra na to. Okay, and this might be something new to some of you, but let's see why this is going to be a perfect square. One option is to multiply out the entire thing. However, when you multiply out the product of n, n plus 1, n plus 2, n plus 3, that's going to be a 4th degree polynomial. Of course, you could use Wolfram Alpha or pen and paper. So you're going to get a 4th degree polynomial, and you have to find the square root. Okay, but let me show you this. Instead of multiplying this completely, I'm going to multiply out n and n plus 3, and also n plus 1 and n plus 2. Because you're going to get two products. They're not going to be exactly the same, but I don't think they're going to be that far apart from each other. So ganito, n and n plus 3, if you multiply them, you'll get n squared plus 3n. And then the second pair, n plus 1 times n plus 2, when you multiply them, you're going to get n squared plus 3n plus 2. So I wanted to be able to exploit the fact that, oh, hey, pareho silang merong n squared plus 3n. So I'm going to try to exploit that. So ng n squared plus 3n, nandito siya. And then n squared plus 3n plus 2, nandito siya. But between them, there's n squared plus 3n plus 1. So here's what I'm going to do. The first factor, n squared plus 3n, let me rewrite this as n squared plus 3n plus 1, and then baba ng isa. And then the second factor, n squared plus 3n plus 2, we could write this as n squared plus 3n plus 1, and then akyat ng isa. All right, so what I've done is I've rewritten that product of two quadratic expressions into a product of the form a minus 1 times a plus 1. Because then when you multiply, that's going to be a squared minus 1. So then we're going to have the following. A squared minus 1, so n squared plus 3n plus 1 to the second power minus 1. And then you see what's going to happen. The first term 1 cancels the last minus 1. And so yes, indeed, we do have a perfect square. In fact, it's the square of n squared plus 3n plus 1. Dun sa calculator work natin, you could verify that if you look at, all right, in cell C1, 24 plus 1 is the square of 5. And for that particular row, the corresponding value of n, so what's the significance of n? N is the first of the 4 integers we're multiplying. So the value of n is what we have in column 1. So if n is 1, you can verify that n squared plus 3n plus 1 in our computation will really correspond to 5. What if n is 2? N squared plus 3n plus 1 will become 4 plus 6 plus 1, and it's really 11. And then if n is 3, so consistent, n squared plus 3n plus 1 will be equal to 19 in cell C3. So when you try to get your hands dirty, look for patterns, so you're just exploring, and then hopefully it becomes clearer what's happening. But you're not going to get any clarity if you're not going to do any exploration. And when you try to explore, when you solve a problem, use whatever tool or strategy or technique is available. So these were from a problem-solving book. And so meron pa talagang ibang mga problems dito from the Philippine Math Olympiad and the Australian Math Olympiad. So ito because Teacher Bads, we're almost out of time. Tama po ba? Teacher Bads, kumusta po tayo? What's the status?
Yeah, we still have, I think, 7 minutes, but we can extend up until 5:20.
Hi, everyone. So I hope you learned something. And then if there are any comments, but I wanted to confirm with Teacher Bad's ano po status. We're up to 5 p.m. Tama po ba?
Yeah, I think, sir, we can extend hanggang 5:20 po. So that our teachers will learn more about your discussion.
Hindi ko marinig eh. Oh, wait.
So we can have an extension hanggang 5:20 po para mas marami po matutuhan ng ating mga teachers. And sir, nakamute po ulit kayo.
To 5:20. So I just wanted to be sure. Okay lang, I could go on.
Yes,
Okay,
po.
good. Okay, sige, thank you. Okay, so this year we're gonna have the 23rd Philippine Map Olympiad. So this is taken from the qualifying stage of the Philippine Math Olympiad from the previous school year. So as a competition, the Philippine Math Olympiad follows the usual trend of it being a pen and paper competition. However, I'm presenting these problems not necessarily for us to join the contest, but just to explore a problem. All right, as we answer the following question, how many natural numbers n are there such that the greatest integer function of n cubed over 9, hold on, sorry, I forgot the rest of the question. The question is that this is supposed to be prime. How many natural numbers are there such that the greatest integer function of n cubed over 9 is prime? Now, that notation I'm using there might not be known to everybody, so let me spend a couple of moments talking about this. So this is called the greatest integer function. Or the floor function. And the first term, so these are two accepted names for this function. The first function explains what it represents. This is supposed to capture the greatest integer less than or equal to x. Greatest integer less than or equal to x. So for example, if you take the GIF or floor of an integer such as 4, then the result is going to be 4. Well, because 4 is an integer. So for 4 itself would be the greatest integer less than or equal to x. So kumbaga, from 4, you look down at itself and anything lower than it and choose the largest integer you see. So it's more exciting if you use it on a number which is not an integer. For example, the floor function or the greatest integer of pi, approximately 3.14. So this is going to be 3. So the output is always an integer. even if what you input is not an integer. And then even for negative numbers, so let's say we're looking at negative 2.1. Now, be careful though, the answer is not negative 2, because if you draw things on a number line, so here's where you have negative 2, and here is where you have negative 3, and negative 2.1 is going to be here, negative 2.1. So you're looking on the left. So we are not rounding off, because negative 2.1 is going to be closer to negative 2. But the largest integer, smaller than negative 2.1, is negative 3. So if x is an integer, its floor function produces itself. If x is not an integer, then you look at all the integers smaller than its value and choose the largest among them. So question, if you compute n cubed and then divide it by 9, well, okay, that's not always going to be an integer. But if you take the floor function, then the result is going to be an integer. The question is, sometimes the result is going to be a composite number, sometimes it's going to be prime. How many times is it going to happen that the result is prime? Or, well, you know, we could always generalize the question, if possible, what are those natural numbers for which n is going to be prime? So I wanted to go through this so we could use a calculator. And not all calculators are equal. Some of them have the greatest integer function, some don't. So in fact, of the two calculators that I used, hindi ko na nabalikan nung isa, nung ClassWiz. Okay, kasi nung table spreadsheet computations natin required lots of columns. So this ClassWiz does not have, as far as I can see, the greatest integer function, pero dito sa CG50 meron. Okay, so I'll show you where it is. So all we got to do is compute n cubed over 9 and then apply the floor function. So on this same table, we already have in column A the integers 1, 2, 3, 4, 5 onwards. We just want to compute n cubed over 9. Okay, so I could delete everything. Let me see if I could remember deleting just particular columns. So I'm exiting and then delete. So F3, just the column. So so I'm gonna access column by clicking F2. All right, and then do the same. Bring it to column B, and then column F2. All right. So I already have 1, 2, 3, 4, 5. Ngayon, how do we access the integer function? Now, in at least the Casio calculators I've seen, if it has a catalog function, then that's where you could access special functions. And in the number pad above 4, we see catalog in orange. So is that orange or yellow? Let's call it orange. Let's click Shift to access that. Shift and then catalog. So click 4. And it's gonna let you in on all these many other functions which you could apply. So you can scroll down. The function we need is called INP for integer, because I've already used it. It's actually in my history. So I'm just gonna access the history on the lower right by clicking F5, because that is what it's gonna correspond to. F5 and int is number 1. So on the number pad, I'm gonna press 1. So, oh, I forgot I should have put the equal sign before it. Equal sign. Shift equals. And then access the catalog again. Shift catalog. And then int. So I'm gonna click number 1. There you go. And then because I will be computing n cubed divided by 9, let me use a grouping symbol. And then n cubed Okay, so alpha A, 1, and then the caret symbol for a convenient exponentiation to the third power, close, and then let's divide by 9. Let's divide it by 9. And then close the group. And then execute. Okay, 0. And actually, if you think about it, you could confirm that this is correct. You could check always if your formula is correct by verifying it for small enough values. If n is 1, then n cubed over 9 would be 1 over 9. So hindi man lang umabot dun sa integer 1. So below 1 over 9 is the number 1. Sorry, the number 0. And then now let's copy this formula. So let's exit, edit, F2, copy, F2. We are ready to paste. So paste here, F1, and then F1, and so on. 37, those are primes. Hey, 13, also prime. Oh, why is 0? Kasi wala nang nakalagay doon. All right, so let's copy the last complete row, A5 with B5. So 2 cells, so let's use clip. Shift, clip. Sorry, I need to, it's in paste mode, so I forgot to exit. Ayan. All right. Shift, and then above 8 is clip. A5 to A5, let's bring it to B5, and then copy by clicking F2 for edit, copy, so F2, and then let's go to the next row, paste, F1. Ayun, composite na, 24. 38, composite, hindi na prime. 56, 81. So I guess you could try, as you're trying to complete the row, let me remind you, column B has the values of the greatest integer function of n cubed over 9. And then we're trying to identify how many natural numbers n there are so that the resulting number in column B is going to be prime. And so far we have up to 13, and then from 24, 38, 56, and 81, they're not prime numbers anymore. I was thinking maybe they're going to be all even numbers. So if we could show that the result's always going to be even, then aside from the number 2, any even number other than 2 is going to be a composite number. However, when we get to this latest row, oh, it's 81. So it's not even. So let's continue. Paste. So F1, multiple of 3, 1, 1, 1, and then 1, 4, 7. Actually, a multiple of 3. So nung mga nauna kanina, we had multiples of 2. You can see if that's something. And then result 81, 111, 147 of 3. Let's see nung kasunod. So paste. So F1, is this a multiple of 4? Yes, it is. Nung next. Multiple of 4. You know what, when I was doing this yesterday, I did not observe that pattern. It's a multiple of 4. Nung next. A multiple of 5. 375. Multiple of 5. Multiple of 5. So it appears that in blocks of 3, the next block of 3 will be multiples of 6. Okay, so that's the pattern, multiple of 6. So, all right. So at least as far as understanding the problem as to how many natural numbers n are there such that the floor function of n cubed over 9 is prime. So our conjecture, so at least we have an understanding of what's happening. Proving it is going to be an entirely different thing. Our conjecture is that the greatest integer value of n cubed over 9 is prime only when n is equal to, so we got the prime results 3, 7, and 13 when the values of n are 3, 4, and 5. So the answer, if it's just the answer we're after, the answer would be 3, because it's a question of how many natural numbers there are that make that expression a prime number. Okay, so at least if you're going to try to find a justification for this, then you just need to prove that, oh, if so to prove this, show that the floor of n cubed over 9 is composite when n is greater than or equal to 6. So ibig sabihin, from n equal to 6 onwards, the results are going to be all composite, meaning we're not going to find any primes anymore. So at least with the exploration that we did here, we have a clear idea of what's happening to the problem. Proving it is a different thing, but we got to start somewhere. Okay. So what I'm going to present now is one of the solutions that were proposed. In fact, here is something else that I'm going to show you. It just occurred to me when I was solving this. In column B, what we got here are the results when you take the floor function. It would be interesting, before you take the floor function, what is n cubed over 9 anyway, before you look at the greatest integer. Okay, so column C, let me just add it. So ito, shift equals, sorry, I always forget to exit the paste mode. Shift and then equals n cubed, so that would be cell A1. So alpha A1 to the 3rd power, and then divided by 9. So it's 0.111, 1 over 9. Let's copy this formula. So F2 copy, and then paste. So F1, 0.888. Oh, actually, exacto 3. And then paste again. 7.1111. And then paste again. 13.888. So at least we could confirm that the results in B are correct. 7 and 13, they're the integer portions. However, notice the non-integer portions. They see how they're 0.111, 0.8888, and then they seem to be all right. And 0.1111, when you repeat the 1, that's 1 over 9. And 0.8888, that's repeating 8, that's 8 over 9. So parang lumalabas nung mga butal lagi. So, well, n cubed over 9 is not all the time going to be an integer. Parang laging may matitira, but it appears that nung non-integer part seems to only be 1 over 9, repeating 1, or 8 over 9, nung repeating 8. Okay? And since we are dividing n by 9, actually nung proof, and this requires na familiarity with proving situations like this, because you're dividing by 9. Okay, let's write n as 3 quotient plus the remainder. So r is the remainder when you divide n by 3, and when you divide by 3, the remainders are only going to be 0, 1, or 2. Tapos the quotient q is whatever it's going to be. So let's see, ano ba talaga mangyayari sa n cubed over 9? This would be the cube of 3q plus r divided by 9. So if you remember the binomial formula, if I remember correctly, okay, this is going to be the cube of 3. So for those who are familiar with the formula, otherwise, for those who remember just the algebra, you could write this out by hand, expand the cube, and sometimes if it's necessary, we just have to do it. And then 3 times the square of 3q and then r to the first, and then 3, and then 3q to the first, and then r squared plus r to the third power, and then divided by 9. So nangyari, as you go from left to right, you write down 3q's exponents going down, 3, 2, 1, and then no more 3q. And then from right to left, the exponents of r go down from 3, 2, 1, and then no more r. And then you have the binomial coefficients 1, 3, 3, and then 1 for the last term. Okay. Or you could actually just expand the cube by hand. Now let's apply the exponents. 27q to the third plus 27q squared r plus 9q r squared plus r cubed divided by 9. The first 3 terms can be divided exactly by 9. So we get 3q to the third plus 3q squared r plus q r squared plus r cubed over 9. As we pointed out earlier, m cubed over 9 is not always going to be an integer because of that very last term, r cubed over 9. But remember, the remainder r can only be 0, 1, or 2, which means r cubed over 9 can only be 0 cubed over 9, which is 0, 1 cubed over 9, which is 1 over 9, or 2 cubed over 9, which is 8 over 9. And then when we look at 1 over 9, 9, you go down the row, the 1, 1 here we found by what indication insert cube over 9. But if you look at the 4 terms that we have here, the first
Hello. Hello. Hello, Sir Buddy.
Hello, Sir Joel. Nakamute pala ako. Kaya na ako nagsasalita.
Wala kang audio.
Let's
Sabi
have
ko
this
wala audio.
problem with the internet connection of our speaker. And while waiting for him, I think let's hear a message coming from the head of the Casio Education and Casio Calculators Philippines, Mr. Joel Serrano. So Joel,
Ay,
kumusta?
mabuti naman. Actually, nag-i-enjoy ako sa pakikinig kay Dr. Eden eh. Feeling
Yes
ko
po.
nasa classroom na naman ako, no?
Yeah.
And actually, we dedicated this session sa tatlong target natin, no? One is para sa mga coaches na
Yeah.
gustong i-guide yung kanilang mga
Winners.
estudyante para sa mga math competitions. Tapos pangalawa, dun sa mga mathletes natin na tinatawag. O sabi nga nila, literally, it's mga kontisera na gustong syempre manalo sa mga MMC, sa mga IMO, PMO. And of
Yes
course,
po.
pangatlo, yung mga parents natin na syempre, may mga parents kasi na talagang very active na sinusuportahan yung mga anak nila
Yes.
Natali sa mga math competitions, no? Para to sa inyo talagang lahat, no? So, nung inisip namin itong concept na to, ayun kagad ang pumasok sa isip namin. Sino yung matutulungan natin, the same time, paano tayo makakatulong, and sino yung the best person na pwedeng tumulong sa atin. And yun nga, si Sir Eden, si Dr. Richard Eden, ang one of the top names na nag-float kagad sa amin, no? Hindi naman tayo nagkamali. Ang galing, di ba?
And I think, sir, ready na ulit si Dr. Richard Eden.
Yeah,
So
go ahead.
let's have Sir Richard Eden again. Hello, sir.
Hi. Siguro tapusin ko na lang yon kasi nag-data na ako eh. Ito nung around this time nawawalan ng internet ang Sky Cable. Oops, sorry. Hindi ko ba pwedeng i-mention yun? Baka ma-pressure sila. Nung Sky Cable, napaka-consistent po. Kaya po tayo nag-move. Alright, 10 a.m. nawalan nga kanina. Tapos medyo napaaga ngayon eh. Yesterday, 5:30 nawalan. Well, 5:19 nawalan. So let me just finish this up. Tapos pwede nyo nang ituloy ng rest of the program. Okay. Sharing the screen. And then, okay. So, okay. Shared na po, no? Okay. So, ibig sabihin, nung R plus 3Q squared R plus QR squared. Thus, ang question, when is this prime? Well, on first appearances, on first look, so in fact, if you factor Q out, you're going to have 3Q squared plus 3QR plus R squared. But see, here's the thing. Just because you have an algebraic expression and the two factors are integers, it doesn't mean it's prime. Kasi what if one of those factors is 1? So, syempre, if you look at, 1 times 7, product of two things, pero prime. Kasi, tamo, ng result 7. So, if this has any chance of being prime, okay, this can only be prime if one of the two factors is 1. So of the two factors, Q and 3Q squared plus 3QR plus R squared, sino pa ba nung pwedeng maging equal to 1? But syempre nung mas maliit, which is Q. So this can only be prime if Q is equal to 1. Now remember, saan pumasok nung Q? Ito nung representation natin for N. N is 3Q plus R. So Q is the quotient when we divide by 3. So ibig sabihin, the only chance we have of the result being prime is if N, which is 3Q plus R, is equal to, if Q is 1, 3 plus R. Tapos nung remainder, ito nung 0, 1, 2. So you just need to check, what if N is 3 plus 0, and then N is 3 plus 1, 4, and then N is 3 plus 2, 5, and then you could check that, yes, indeed, nung N cubed over 9, which we already computed from our table earlier, they are indeed going to be prime, 5, 7, and 13. Okay, so prime numbers. So with this, we have wrapped up the solution nung ginagawa natin, sinasolve. It was initially a question, how many numbers N make that expression prime? Pero konti lang naman sila. So pinakita natin na actually from N larger than 6 onwards. Kasi when you divide 6 onwards, nung value of N by 3, lalabas ng quotient will be at least 2. So mangyayari, nung greatest integer, nung smaller factor niya, hindi na 1. 2 na at least. So composite na siya. So I'm gonna stop here. So I'm gonna hand this over to you, Sir Joel and Sir Bads. Thank you very much for giving me the opportunity. And I understand maybe mahirap, maybe this is all new, but that's really part and parcel of problem solving. So if this is something new that you have encountered, so we don't have to be too hard on ourselves na ay hindi ko naintindihan lahat kasi I mean hindi mo din naman talaga maintindihan lahat eh. Our context is very limited and problem solving skills these are not something that you get to develop overnight. It takes many years. I remember when I was a student I was flustered by all these problems, but I kept at it. I was able to join contests and well the students these days they're so much better. So ako as a teacher I try my best to train students, and I'm always gratified to see that our students, the ones I encounter, are so much better than I am. And I think that's really promising. And I hope that eventually they could carry the torch and teach future generations. Thank you very much. Magandang hapon po sa inyong lahat.
Thank you, Sir Dr. Richard Eden, for that very wonderful presentation. Alam ko, medyo nagkaroon pa tayo ng parang kulang yung oras for this particular topic. Talagang napaka-comprehensive. And sabi nga Sir Joel kanina, no, very rich in content ito kasi hindi lang ito for mathematics teachers. It encompasses different professions na yung mga magulang na talagang pag may content na kanilang mga anak ay talaga nandiyan para sumuporta. And since based on the bio note of Dr. Eden, talagang it focuses more on developing problem-solving skills to our learners. And talagang mahirap yun kasi once you develop mathematical skills of our learners, medyo it's another way on how you develop yung pagiging problem solver nila, the way they understand the problem and the way they comprehend the content of the problem. So talagang itong mga math coaches natin, yung mga sumasali sa MMC, sa mga MATHtech Math Challenge, mga Math Olympiad, International Math Competitions, I think talagang nakatutok sila dito sa session natin ngayon. And we are very lucky to have Dr. Richard Eden as our speaker. And we would also like to express our sincere thanks to Mr. Joel Cicerano, our Casio Education Unit Head, for sponsoring and for spearheading this kind of session. And para sa ating closing, let's have a message coming from Mr. Joel Cicerano, our Casio Education Unit Head. Mr. Joel.
Yeah, good afternoon, Sir Eden. What can I say? Yeah, congratulations.
What can you say? Joke lang.
Congratulations.
No, salamat. Matagal ka nang kilala si Sir Joel.
Very nice presentation. Actually, may nag-text sa akin dito eh. Sabi niya, wala na ba? More to come daw, sir. Bitin daw eh. Parang sila. Sabi ko nga, yan nyo, pag okay na yung connection ni Sir Eden, dire-dire yan. So, congratulations, Sir Eden. I think you're one of the best talaga nakakadim.
Ball.
Yeah. Yeah. Anyway, what should I say? Yun sa may sinasabi Sir Eden.
Let's wait, sir. Medyo nagkakaproblem lang sa...
nagkakaroon ng difficulty na si Sir Eden kasi sabi niya sa akin kanina, ganitong oras talaga nasisira na yung internet niya. Anyway, sa ating mga participants, we hope marami kayong natutunan for today. And nakita niyo naman yung software na ginamit ni Sir Eden. It's for free. You can download it sa aming educational website, edu.casio.com. Ngayon, kung nagustuhan niyo yung aming product lines, you can simply visit our official social media pages, CasioCalculatorsPhilippines.com, and we can lead you where to get where to score our calculator products. No. Again, maraming salamat, Sir Eden. Congratulations ulit, no. And hopefully we can invite you again in our future sessions. Thumbs up.
Thank you, Sir Joel. Let's have our speaker, Dr. Richard Eden, sir. And the last message to our viewers, our math teachers and math coaches all over the country.
Okay, last message. When I talked about problem solving, so hindi kailangan sa level ng Math Olympiad. Just, try to spice things up a bit. Medyo ibahin nung mga problems kung kaya. Pero ultimately, I understand ng limitation, especially this year. Okay, so even though I teach in college, I have kids and they're also doing their online class.
Wala na, nasira na sir.
So, may mahirap din, but ultimately, I would never pretend to know more than that there's, and so gradual baby steps, pakonti until.
Ayan, so thank you, Dr. Richard Eden, and I think this will be the start of more sessions with Dr. Richard Eden, if I'm not mistaken. Next week, we'll be having another professor coming from the Ateneo de Manila University who will be discussing another topic about mathematics. But for now, thank you, Sir Joel C. Serrano, and thank you, Dr.
Thank you.
for this very wonderful session. And I know lahat ng mga teachers natin ay maraming natutuhan sa ating session this afternoon. Again, thank you, Sir Joel Serrano, and thank you, Dr. Richard Eden. And that concludes our 18th session of our It's a MATHtech Day Casio Technology session spearheaded by Casio Education Philippines in partnership with Educational Technology Unit. So next week we'll be having another session with a very knowledgeable and competent speaker who will be discussing to us another techniques on how to solve different mathematical problems. But for now, tulad na namin natin sinasabi, malapit na magpasko, it's the spirit of giving, loving, and sharing. Sama-sama tayo, tulong-tulong tayo sa pagsulong ng edukalidad sa ating bansa. Again, thank you and God bless us all.